Hello, my name is Ian. I'm an engineering ambassador at Rensselaer Polytechnic Institute, and I will be guiding you through the current solar panel program. In this program, I will be teaching you about circuits, soldering, solar panels, C++ code, and Bluetooth and signals. Learning these skills and concepts will enable you to understand the device that you will be building. You will be learning through activities, demonstrations, and presentations. The end goal is to create a working solar panel device that can wirelessly send data to your phone or computer. Here are the two solar panel devices that were created by RPI graduate students and REU students. The second version on the right is the one you will be learning about and constructing yourself. The device was first created to collect solar radiation data to simulate solar panels on the military grid. From the collected results, soldiers could fairly accurately analyze how much power massive solar panels would generate in certain areas on the grid. As you can see on the right, their microgrid would consist of solar panels, wind turbines, and other sources of power. They would use this power to run all their operations. This program consists of 6 sessions, each of which you will learn new concepts and skills in order to both help you build and understand the solar panel device. The first session you will be learning about circuits and soldering. The second session you will learn about Arduinos, current sensors, and IDEs. The third session you will learn about solar panels and begin your main experiment. In the fourth session you will learn about C++ code and test out your devices so far. The fifth session you will learn about signals and Bluetooth. The last session you will finish your experiment and have a small quiz on what you learned during the program. In this session, you'll be learning about circuits and soldering. In order to understand circuits, we first have to ask, what is a battery? Well, it is a container in which chemical energy is converted into electricity and used as a source of power. It consists of a cathode, anode, and electrolyte. A cathode is a positively charged electrode, and an anode is a negatively charged electrode. You could think of them as conductors with a specific charge. A conductor is a substance that can easily transport charges or electricity. The anode is negatively charged because it releases electrons. It also releases ions in the electrolyte in order to form a current between it and the cathode. The cathode, on the other hand, is mostly absent of electrons. Due to this, electrons will flow in the external circuit from the anode to the cathode and create a current where you can power devices such as the light bulb in the image. An important note to make is that even though the electrons are moving from the anode to the cathode, current is said to go the opposite direction because we define the direction of current as a flow of positive charges. Now let's talk about Ohm's law. The law tells us that the voltage is equal to the current multiplied by the resistance. Voltage is the potential difference between 2 points in a circuit. You could think of this as the pressure in a water pipe. The current is the measurement of the flow of electrons, or electricity. Think of this as how fast the water is in the pipe. Lastly, the resistance is the measurement of how much current flow is restricted, which is similar to how wide a water pipe is. The last measurement we'll be talking about is electrical power, which is the rate of which electrical energy is transported through a certain point in a circuit. We can use the equation power is equal to the current multiplied by the voltage in order to find the power in watts. The image on the right demonstrates how a light bulb needs a voltage and current in order to generate power and produce light. The battery is supplying the voltage, and because there's a complete circuit from the positive side of the battery to the negative side, a current is produced. This results in the bulb lighting up due to the resistance inside it, which is transforming that electrical energy into power in the form of light. However, if we have a voltage and resistance but break the circuit by lifting the switch, we can stop the current and turn the light bulb off. This is because there has to be a complete pathway for the electrons to flow from the negative terminal of the battery to the positive. With no electrons flowing, the bulb has no way of producing light. Now, I will talk about the 2 types of circuits, a series circuit and a parallel circuit. In a series circuit, all the resistors are right after the other. You could think of them as one massive circuit by simply adding them up. Resistors are simply electrical components that slow down the flow of the current. They also convert electrical energy into heat. Now, a parallel circuit, on the other hand, has resistors that are not right after the other and allow the current to flow between either one in different quantities. Think of a series circuit as customers in a grocery store with one checkout. The customers are electrons and the checkout is the resistor. Because there is only one checkout, there is a ton of resistance and only one path for which the customers can flow. This slows down the flow of electrons or customers in this case. For a parallel circuit, you could think of the same analogy, but now there are multiple checkouts. This results in a higher flow of customers. Sometimes there are different valued resistors in a circuit. When this occurs in a parallel circuit, each resistor creates a different current, sort of how in a grocery store there could be fast cashiers and slow cashiers in checkouts. Let's go over how to calculate current in a series circuit versus a parallel circuit. In a series circuit, the current remains the same, so we can find it by taking the voltage and dividing it by the total resistance. This equation is the same as V is equal to I times R, but manipulated so we are solving for I, which is current. Now, if we add the resistors together, we get the total resistance, which is 18 kiloohms. We can then put the 9 volts and 18 kiloohms into our equation, and we will get 0.5 milliamps. Let's now switch over to the parallel circuit. Each resistor produces its own current. Even though each has a different current, they share the same voltage, which is 9 volts in this case. So in order to find each current, we simply use the same equation before, but now we don't have to add up each resistor. We simply put the 9 volts and the resistor's value into each equation and we will get the current for each. As you can see, the currents are relatively bigger than that of the series circuit. Why is this? Well, it's similar to our grocery store analogy. Because the electrons are allowed to flow in different pathways, the current is much greater because they can pass through much more easily than if it had to go through one big resistor, as they would have in a series circuit. When I say one big resistor, it is because in a series circuit we could think of all the resistors together as one massive resistor. For this example, the big resistor would have a value of 18 kiloohms. LEDs, also known as light-emitting diodes, are similar to resistors in the sense they can convert electrical energy into another source of energy. However, instead of heat, they convert electrical energy into light. In addition, they have a much smaller resistance than resistors, which means you have to be careful attaching a battery to an LED directly, because it would allow a massive current and burn out the LED. They work in the sense that when electrons flow through it, the electrons will release energy in the form of photons or light. This is due to the fact that electrons will drop from a higher orbital to a lower orbital. You'll learn more about this in your chemistry class. Before you start your activities, we have to go over what a breadboard is. A breadboard is what engineers use to test their circuits before soldering. The positive and negative strip goes down vertically. You will want to attach your positive pin and negative pin from the battery to the correct hole indicated by the charge symbol. The other places are for the electrical components, like LEDs and resistors. Instead of going vertically, the inside has wires going horizontally. An important note to make is when adding things such as an LED, you will want to attach each prong on separate horizontal holes as shown above. This is because if we put them on the same row, no current would flow through it due to the fact that electrons would rather go through the hidden wire inside with less resistance, rather than the LED itself. Also, the longer end of the LED should connect to the positive side of the circuit and the smaller prong to the negative side. Now you're going to start your first activity. Work individually or together to figure out how many LEDs can be in series. Keep going until the LEDs won't light up anymore. In this video, I'll be showing you how to create a series circuit and a parallel circuit. What you'll need is a 9-volt battery, a breadboard, a resistor between 20 ohms to 1 kiloohm, a couple of LEDs, and some wires. You'll start by taking the positive side of the 9-volt and place it in one of these holes, and the ground into one of these holes. As you can see on the breadboard, we have 9 volts that are going to be going through all these holes vertically here. And then we have ground through these holes. All these holes will be placing our resistor and LEDs, so we have a clear pathway between the positive side to the negative side. So Let's start by taking a resistor. This one's around 20 or 200 ohms, and we'll place it here. In a series circuit, we have to make sure that each piece of equipment is right after the other. So we're going to take an LED and have the longer side go into the positive side. Now we're going to take another LED and we're going to make sure that there's a clear pathway between here to here. So what we're going to do is take this LED, place it here, and take a wire and connect it here. As you can see, the LEDs have turned on. This is because there's a clear pathway, as demonstrated here, that goes through here, through the resistor, through the first LED, through the second LED, and through the wire to ground. So we're going to figure out how many LEDs we can put in series. So let's take these out, make it look a little better so we can put more together. So here, place one here, place one here, and place one here. As you can see, there's 4 LEDs lighting up. Now let's try adding one more. As you can see, they all turned off. This means that the most we can put in series is 4 LEDs, demonstrated here. Now, figure out how many LEDs can be placed in parallel. Make sure you use the same resistor as you did in the series circuit. In addition, think about why there is a difference. Okay, now I'll be showing you how to create a parallel circuit. We're going to start by taking the 9-volt battery and establishing the positive side and the negative side on the breadboard. Now, let's add our resistor. And as you can see, it's very similar to what we had in a series circuit. But the difference now is that we're going to create a parallel circuit, which is different because the 9 volts is actually going through all the resistors at the same time. So we're going to take the longer end of the LED and place it in the same row as the resistor, and I'll take our next one and do the same thing. You can see that this is a little different than a series circuit because they're actually right next to each other and not right after each other. So let's take our wire, connect it to the smaller side of the LED, and connect it to ground. As you can see, they're on. And in a parallel circuit, the longer end is in the same row as the resistor, and the shorter end is in the same row as the wire going to the ground. So now let's see how many we can put in parallel. So take the wire out and add a couple more LEDs. As you can see, I put them on the other side of the breadboard. In order for them to be on the same row, we have to use a wire and connect them together. I'm actually going to move one of these LEDs to the other side so we can actually add the wire in. Now let's add a wire for the ground side of the LEDs to connect. As you can see, that the longer sides of all the LEDs are connected through this wire, and the shorter side through this wire. So if we add a wire from this one to ground, they should all light up. as you can see here. Same row on this side, same row on this side. So let's keep on adding more LEDs and see how far we can go. So I'm going to take one from here that's on the same row as this one, and let's move it down here. And have the same thing go for the shorter side of the LEDs to go to ground. Now let's add some more LEDs. Now take our last wire and connect it to the negative side of the LEDs and then to ground. As you can see, all the LEDs are turned on. The reason why you can put more LEDs in parallel is because each LED is using the same voltage after the resistor. While in series, the voltage goes down progressively after every LED. In addition, LEDs in parallel have a much lower resistance than those in series. This results in the current remaining relatively high when adding another LED in parallel. This is a challenging activity and will require more thinking. What you have to do is create a circuit using only one resistor, one push button, 4 LEDs, and as many wires as you need. The goal of this activity is to have 2 LEDs on at the start. But when the push button is pressed, the original LEDs will shut off and the 2 new ones will be on now. Think about how the overall resistance of a series circuit and how it is different than a parallel circuit. In this video, I'll be showing you how to create a 4 LED circuit with a push button and allow only 2 LEDs on at a time. You'll need a 9-volt battery, 4 LEDs, a couple wires, a resistor between 200 to 1 kilo ohm, and a push button. We're going to take our positive side of the 9 volts and established to the breadboard, the negative for ground to this side. Now we're going to add our resistor here and our push button here. As you can see, these are on the same row, and this one is not connected to anything yet. Now, how this works is that we're going to have the 2 LEDs in a series circuit that's going to be totally on at the first time. Then, as we push the button, we're going to have a parallel circuit that turns on. So let's do that. We're going to have an LED connect to the same row as the top of the push button and the end of the resistor, and have another LED in series to this one. Take one of our wires and connect it to ground. As you can see that they're on. Now we're going to take the last 2 LEDs and create a parallel circuit that's going to be to the end of the push button here. So place the longer ends of the LED in the same row as the push button, and have one of our wires connect to the same row as the shorter end of the LED and attach it to ground. So when we touch the push button, the 2 LEDs in the series circuit should turn off, and 2 LEDs in the parallel circuit should turn on. The reason behind this is because the electrons would rather go from a less resistive pathway than a more resistive pathway. Because a series circuit has more resistance than a parallel circuit, when the pathway to the parallel circuit is allowed when pushing the push button, the electrons would rather go through the parallel circuit. Now you are going to learn how to solder a simple circuit shown on the image. You have to make sure you are being safe at all times. Never touch the metal part of the soldering iron and wear safety glasses. So in this video, I'll be showing you how to solder a series circuit. But before we do that, we have to make sure that we have our safety glasses. What we'll need in this activity is a 9-volt battery, a circuit board where we can solder, a resistor, LED, a couple wires, some solder, and a soldering iron. So first, we're going to take our positive side of the battery and solder it to one of the vertical sides on the circuit board and solder it right here. So let's start that. Make sure you're not touching any place where the metal is because it's going to be very hot. Take some solder, put it right over the hole, and just gradually heat up the solder, and it should just stick right to the wire. Turn it around, do a little tug, stays in place, so we're good. Now let's add the negative wire in. Now let's check our connection. Good. Now let's add our pathway between the positive side to the negative side. So we're going to have a resistor here, and the LED here. Take our resistor and place it right here. Turn it around. And then we can bend it to make it easier for us to solder. Solder one side and the other side. Now let's add our LED. Make sure that the longer side of the LED is going to be connecting to the resistor. Flip it over. Place it, longer end, on the same row as the resistor. Fold it over, fold this side over. Put a little solder on, and a little solder on that side. Now we're going to take our wire and connect it to the smaller side of the LED and then to ground. Make sure it's on the same row. Now let's move it to the ground side. As you can see, our LED is on and the whole thing is soldered. This concludes session 1 of the Current Solar Panel program, and I leave you with this quote. What we usually consider as impossible are simply engineering problems. There's no law of physics preventing them.